Two-digit number is multiplied by its reverse, and the units and tens digits are both 0. What's the value of the smallest such two-digit integer? So I went into algebra to do this and wrote AB as 10A plus B. For example, you could write 37 as 10 times 3 plus 7. Then if we reverse it, for 73, we'd get 10 times 7 plus 3, which means that BA is going to be 10B plus A. I'm going to multiply these two together. This does require some knowledge of expanding double brackets. I'm going to talk a little bit about how we do this. It comes from the fact that you could make this into a rectangle. So let's say that this length is 10A and this is B, this is 10B and this is A. We end up finding these four little areas by timesing across and then adding them all together. So I'm going to do 10A times 10B, which will give me 100AB, and then I'll get 10A squared. Then I need to multiply here because you can see I've dealt with that one and I've dealt with that one. Right now it's this one. It's going to be 10B squared. And finally BA, or AB, I can leave it as. Now, it might be tempting to simplify this to 101AB, but remember, we're interested in it being a multiple of 100. So I've already got a multiple of 100 here, regardless of what A and B are. So actually, I'm going to focus on the remaining terms. I need this to be a multiple of 100. And the only way I'm going to manage that is if AB is a multiple of 10. Okay, if it's not, there's no way we get a multiple of 100. So I'm just going to say that I'm going to be a multiple of 10 and to use two digits to do this. One of them is going to have to be 5. So let A equal 5. We could let B equal 5. It's not really going to matter because we're reversing it. Let A equal 5 and B must then be even. So 25 would be the smallest possible number. And actually, we can see this is going to work. 25 times 52 is going to give us, because 52 is a multiple of 4. So this will work. So basically, I've done all this algebra. I've got this result up here. And then I've just, I've noticed that I have to have AB as a multiple of 5, sorry, multiple of 10. So one of them is going to have to be multiple of 5, or in fact 5, because remember they're single digits. The other ones are going to have to be even to get a multiple of 10. I've gone with the smallest possible one and then reversed it and seen that this is a multiple of 4, and so that's definitely going to work. So our smallest number is going to be 25. I just want to say a little bit more on this. So how do we get our multiple of 100 overall? Well, it's going to be 10 lots of A squared plus B squared. So that is 2 squared plus 5 squared. That's 29. When I add another 10, I am going to get 300. So that's why it checks out here. One other way to do this question that the solutions do is they kind of spot straight away, without doing all of this, that one of A and B must be a multiple of 5 because when you multiply the number together, we get a multiple of 5. So it must be that one of the original numbers is a multiple of 5. And the only way that can happen, therefore, is if one of them is 5. And so again, so they don't do the algebra, they just say, for example, that A is 5. And then to get a multiple of 100, we're definitely going to need B to be an even number. Because if you have, say, 15 or anything like 25, 35, and you times it by an odd number, it's not going to become a multiple of 100. So in that way, we could say B must be even. And then it's again a case of trying out the smallest even number. 25 works, so we don't need to check any further. So my way is quite complicated, but I think it's, good to see. If you can do it a bit more quickly, then fair play.